Hello my friends, alright, are you ready to start this big implementation of your very first artificial brain? Well, I'm definitely ready, so let's do this, let's smash this together. Alright, so we're going to start with the data preprocessing phase, which we will tackle in this same tutorial because we quickly want to get to the interesting stuff. So let's do this efficiently thanks to our data preprocessing template, but also our data preprocessing toolkit, and therefore the first thing we're going to do here is to import the libraries. So we're going to create a new code cell here. We're going to go into our data preprocessing template to steal the cell we want, meaning this one, and get it back into our implementation, the first cell. All right, so that's the first thing. However, I just want to show you something extra. It is about the beauty of Google Colab. I want to show you that indeed TensorFlow 2.0 is already pre-installed in Google Colab. You know, in any Google Colab notebook you will ever open. So the way for me to show you this is to first import TensorFlow because, okay, it is already pre-installed as a library inside the notebook, but we still need to import it. And in fact, here, since we will actually won't use matplotlib, we're just going to delete this import of this library and then just add as a third library here, well, TensorFlow. And the way to import TensorFlow is start with indeed import, then the name of the library, which is TensorFlow, of course. And then we add a shortcut, a simple one like TF, the classic one. Okay, and now I'm going to create a new code cell, and inside I'm going to enter the following TF dot double underscore version double underscore again. And this will simply print the version of TensorFlow we're using, which I just want to show you is indeed TensorFlow 2, right? The brand new TensorFlow. So let's do this. First, we need to execute this cell, then this one. But remember, if we execute this cell now, this will take some time because actually the notebook is not running yet. And the way to run this is just to click this folder here, right? And it is now that it will connect to a runtime to enable file browsing, but mostly to, start running the notebook, okay? And at the same time, let's take that opportunity to upload the dataset. So please go to your machine learning A to Z codes and datasets folder, which you had to download either in the previous tutorial or at the beginning of each practical activity. So there we go inside. Then part 8, deep learning, almost close to the end, by the way. You must be very excited, almost seeing the tip of the tunnel. Then let's go to this section on artificial neural network. Let's go to Python and let's select this dataset, churnmodeling.csv. Open. Okay. And there we go. Now we have everything. We have the dataset, and besides, our notebook is already running. As you can notice, it takes a little bit more time than usual because, the dataset is this time more real world and mostly bigger. Okay. All right. So let's do this. Let's run this first cell here to import the libraries, this time NumPy, Pandas, and TensorFlow. And now let's play this cell to indeed reassure ourselves that the TensorFlow version we're going to be working with is 2.2.0, basically TensorFlow 2, which is so much better than TensorFlow 1. I'm so happy about their new version. Okay, great. So it's good to have the confirmation. And now let's tackle this part 1 data preprocessing. We're going to do this efficiently thanks to our data preprocessing template and toolkit. So let's create first a new code cell to import the dataset, which we already have in a notebook. Perfect. So let's go to our data preprocessing template. And let's now steal this second cell to import the dataset. All right, let's go back here and let's paste that inside. And now, of course, the question is, what do we need to replace? Well, the obvious first change we need to do is the name of the dataset, which this time is not data.csv, but churn underscore modeling.csv. Great. Then let's look at the rows one by one. This one is okay. Now, what about this one? This line of code creates the matrix features X, and the way it does this is it takes all the columns except the last one. But let's actually have a look again at our dataset, right? We noticed when I described to you the dataset that the first columns are actually irrelevant in the sense that they won't help to predict the outcome of the dependent variable. And these columns are, the non-helpful columns are obviously this one. This just gives the row number of this dataset, so we clearly don't want to include it. Then customer ID as well, right? The customer ID is just a key identifier of each customer because each row corresponds to a different customer. So of course the customer ID has absolutely no impact on the dependent variable exited, so we will also exclude that column. We don't have to, the neural network will just figure it out, but let's just ease the learning process of our future neural network, right? We're all on the same boat here. Okay, then what about the surname? Does the surname have an impact on whether the customer will stay in or leave the bank? Well, absolutely not, right? The surname, of course, has no impact on the decision of a customer to stay in or leave the bank. So we will also exclude this column. And then all the rest, all the other features here look fine. They might have an impact on the dependent variable, meaning they might help to predict if each customer will stay in the bank or leave the bank. Okay, so we will definitely keep all the other ones, meaning all the features starting from this one, the credit score. And so here in our implementation, instead of taking all the columns except the last one, well, we will take all the columns starting from this one except the last one, meaning all the columns from credit score up to estimated salary. And the way to do this is still to keep that upper bound of the range, finishing at the one before last column, right? That's exactly the upper bound, that's the range, but at the left of this range, we won't specify nothing, which means the first column, the first index, but instead we will specify the index of the column we want to start with, which is the credit score, right? We know we want to start from here, and therefore now the question is, what is the index of that column? Well, let's see. Indexes in Python start from 0, so this has index 0, then this has index 1, this has index 2, and this has index 3. And therefore here, instead of specifying nothing here as the lower bound of the range, well, we will specify the index 3, so that we can take all the columns starting from the column of index 3 up to the one before last and taking all the rows, all the values of the dataset. And this will create a relevant matrix of features. Perfect, so this line of code is done. Now what about the next one? Well, obviously the next one is fine. It will just take the last column of this dataset, which is exactly what we want for our dependent variable exited. So all good here, nothing to change. We can just play the cell and we will have our dataset, our matrix of features, and our dependent variable vector. Let's check it out actually. Let's create two new code cells, right? One where we will print the matrix of features X and one where we will print the dependent variable vector Y. Perfect. All right, so let's do this now actually. Let's play first this cell to print the matrix of features X, and there we go. We have indeed all the features starting from the credit score. This is the credit score. Then the country of residence, then the gender, and all the other ones. Has credit card, yes or no, is active, and the last one is the estimated salary. Okay, so we have all these features, perfect, and of course we don't have the dependent variable values because they are right here in Y, and there we go. These are all the decisions of the customers to stay or leave in the bank. So of course this one here corresponds to this customer here, which obviously has decided to leave the bank, right? This is actually this same one here, exited one, and then, well, this second customer has decided to stay in the bank and corresponds to this one, right? Which is exactly this one as well, okay? This customer. All right, so all good so far. First step of the data preprocessing phase done successfully. And now let's move on to the more advanced steps of our data preprocessing phase, which is about encoding the categorical data, right? Of course, we noticed that there are two categorical variables. This first one giving the country of residence of the customers, and the second one giving the gender of the customers. So we'll have to do some encoding work here to encode these categorical data in either simple labels, 0 and 1 for the gender, or some one-hot encoding for these categorical variables in which indeed there is no relationship order between these values, between these categories, France, Spain, and Germany. Okay, so let's do this. Let's start first with the label encoding of the gender column. So let's create a new code cell. And now, of course, to do it efficiently, we're going to go into our data preprocessing toolkit. We're going to scroll down to find, by the way, there is no missing data in the dataset. I checked them, and in reality, you would also have to check them, but all good. We don't have to take care of any missing data. So we can directly move to encoding categorical data. And now, since we're taking care of label encoding the gender column, well, we're going to take this. That's exactly the tool we need to perform label encoding. So I'm stealing this code cell now. I'm adding it inside our notebook here, our implementation. But remember that in our data preprocessing toolkit, we did this on the dependent variable vector. But now we want to do it on this specific column of the matrix of features X. And therefore, what we only need to replace here is this Y by that specific column of the matrix of features X to which we want to apply label encoding. And so, well, now the question is, how can we get this column? Well, we just need to get the index and then call X with that index. And so, well, there we go. That's the first column of X, it has index 0. That's the second column of X, it has index 1. And that's the third column of X, which has index 2. And therefore here, we simply need to replace Y by our matrix of features X, of which we're going to take all the rows, and I'm taking them with this colon, which means a range in Python, and then to take the column we want, meaning the gender column, which has index 2, well, I just need to add here after the comma the index 2, so that it will take all the rows, but only the column of index 2. And now, of course, we need to take this and paste that inside the fit transform method called from our LE object, which is an instance of the label encoder class. And done, we just performed successfully label encoding to the gender column of our matrix of features X. Let's make sure it's the case by creating a new code cell here and do a new print of the matrix of features X. Let's run the cell, first. All right, good. And now let's print X, and let's just make sure that we no longer see female, 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 male, female, but whatever encoding there was, which probably will be 1 for female, or 0 for female, and 0 for male, or 1 for male. Let's see what they did. All right, and there we go, right? That's the new column after the label encoding, and so female was encoded into 0, and male was encoded into 1. That's, of course, a random decision of the machine to choose this integers associations. So all good. Now this column is well label encoded, and now we're going to proceed to the one-hot encoding of the geography column. And this time we have indeed to perform one-hot encoding because there is no order relationship between France, Spain, and Germany. So we couldn't, encode France into 0, then Spain into 1, and Germany into 3. We have to perform one-hot encoding instead. And so let's do this. Let's go back to our data preprocessing toolkit. Let's take that cell this time, which is exactly a cell that perform one-hot encoding, and let's paste it inside a new code cell to one-hot encode the geography column. All right, now the question is, of course, what do we have to replace or change in that cell to indeed perform one-hot encoding on the geography column? Well, remember, the only thing that you have to change inside this code is that index of the column you want to apply one-hot encoding on, right? And remember that in our data CSV file of our part 1 data preprocessing, well, the categorical variable with the 3 different states was in the first column. That's why we had index 0 here. But this time, this column is actually the second column. Therefore, it has index 1. And therefore, very simply, we just need to replace 0 here by 1. Okay, and that's it. All the rest will be done automatically. Let me show you this. Let's play that cell. And now let's create a new code cell to print again X. All right, good. And now let's play that cell and see what X has become. And indeed, well, remember when we perform one-hot encoding, well, the dummy variables are actually moved to the first columns of the matrix of features. So we have them exactly here, in the 3 first columns. So let's see how the one-hot encoding was done. This is the first combination of dummy variables, which corresponds to France. These are the same rows here, and therefore France was encoded into 1, 0, 0. Now Spain was encoded into 0, 0, 1, and finally Germany was encoded into Well, this one, 0, 1, 0. Okay, so that's our one-hot encoding. Then we no longer see the gender column, but no worries, it is still here. And so perfect, one-hot encoding was not only done successfully, but also was done efficiently, thanks to our data preprocessing toolkit and template. Good, now let's move on to the next step, which is to split the data set into the training set and the test set. And once again, we're going to do that so efficiently, thanks to this time our data preprocessing template. Indeed, we have to steal now this cell that splits the data set into the training set and the test set. So let's paste that back into our implementation in a new code cell right here. And now we can just trust this 100%. We will just play that cell and we don't have to do a print of these 4 entities. We perfectly understand how they work, but feel free to do it if you want. You're free to do any modification in this copy, of course, of the notebook. And finally, we have a final step of our data preprocessing phase, which is feature scaling. And now I want to say something very, very important. Feature scaling is absolutely compulsory for deep learning. Whenever you build an artificial neural network, you have to apply feature scaling. That's absolutely fundamental. And it is so fundamental that we will actually apply feature scaling to all our features, regardless of whether they already have some values of 0 and 1, like the dummy variables, and same for these ones. We will just scale everything because it is so important to do it for deep learning. So the feature scaling step here will be very simple. We will just take our data preprocessing toolkit. We will go right at the end because I think this is our last tool. Yes, there we go. We will take that full cell and we will paste it right back in a new code cell just below feature scaling. We'll paste that here, and now instead of selecting some specific indexes here, we'll just take everything. So I'm just removing all our index selections here, right? So that we can just scale everything. And that's the way it should be for neural network, for building and training a neural network. All right, so perfect. This will just apply feature scaling to all the features of both the training set and the test set. But of course, our scalar object is only fitted to the training set, right? Remember, it's to avoid information leakage. So that doesn't change, but there you go. Now we have the code to perform feature scaling already. So let's do this. Let's run this final cell and then the data preprocessing phase will be over. So congratulations. I hope we did it efficiently enough for you. That's the way it should be. I'd like to remind, by the way, that the data preprocessing phase counts for 70% of the work of a data scientist. So that's why it was really important for me to give you some very efficient data preprocessing template and toolkit so that, as you can see, we can do it efficiently in less than 20 minutes. In less than 20 minutes with my explanation, but without the explanation, even in less than 10 minutes. So I hope you understand and appreciate the importance. And now, my friends, it is time for the exciting step, the exciting part of this implementation. I'm talking, of course, about part 2, building the ANN. So there we go. Recharge yourself with good energy, and as soon as you're ready, let's tackle together part 2, where we're going to build for the first time an artificial brain leveraging TensorFlow 2.0. I can't wait to see you in the next tutorial, and until then, enjoy machine learning.